Okay, we're going to look at the final part of iteration. So we've looked at showing solutions exist between two values. We've looked at rearranging, and now we're going to look at using iterative formula. So specifically, I need to show you about xn notation. I need to show you about the process, and then also how to use the answer key for this. So back to the example question that we've used. This is what a typical question looks like. We know how to do part A. We know how to do part B. Now part C, it says starting with x naught, and that 0 is a subscript, is equal to 1. Use the iterative formula, and then it gives you a formula to use, and it tells you how many times to use it. Sometimes it doesn't tell you how many times, but we'll look at that later. To find an estimate for the solution to the equation that you would have been given in part A. So in particular, things to notice with this, the iterative formula that you've been given involves this notation. So you've got xn plus 1 is equal to something, and then within that something you're going to have an xn. So in this case there's our xn. The other thing you should notice is this formula is essentially just the one from part B that you've rearranged. And that is always going to be the case. You can see you're going to be able to rearrange this. And what this is going to do, just without going into too much depth, because it does really go into year 13 territory, you don't need to explain why this works, but this is going to be a formula that will help us find the solution to the original equation without having to plot the graph, without having to rearrange by itself. We're just using this process. So before I show you why that works, we need to look at the notation. So let's look at that. So you may notice the subscript n plus 1 and then the subscript n. Well, let's look at some examples here. So you can show a sequence of numbers like this, where xn is your nth term of a sequence, xn plus 1 is going to be your n plus 1th term, or in other words your next term, the term after the nth term. And then you can also have xn minus 1, which would be the previous term, or you can continue going in this direction. You can have xn plus 2 and so on. And this is a way of labeling the order in a sequence. So what you will find, like we looked at in the example in the previous slide, x naught is usually used as a starting point for this type of sequence formula that we're going to look at. So let's look at an example of a basic sequence formula, how to interpret what this means. So we can see we've got xn plus 1, so that basically is telling you the next term is equal to the previous term take away 3. And rather than writing out this in words, we can just use this notation here. Now notice that this doesn't make sense unless you know what the previous term is, and in this case it tells you the first term is 10. So x1 is 10. To find the next term, we're going to do 10 take away 3 to get 7, and then to find the term after that, we're going to do 7 take away 3 and so on. So this is what it would look like. So the first term is, we know that x1 is 10, so 10 take away 3 is 7. And then the next term will be 7 as your previous term. So 7 take away 3 is 4. And then we're going to do 4 take away 3 is 1, and we can keep going. So this idea of using this notation, where you've got the next term and the previous term, is going to be important for part C of iteration questions. So we're going to look at an example here. So again, still keeping it relatively simple. Have a go at working out the first 3 terms here. Remember that your starting term is x naught equals 4. And then you're going to put that into here. So find the next term is going to be 7 times the previous term, take away 3. So what that will look like is, we know that 4 has to be the first thing that goes in. We're going to multiply it by 7 and then take away 3. And that's going to give us 25. So that's our first term is 4. So that's x naught. x1 is what we've just found, which is 25. x2, well, to work out what x2 is, I'm going to do 7 times x1, take away 3. So 7 times 25, take away 3. And that's going to give you 172. And then to find what x3 is, we're going to put 172 as our input. So 7 times 172, take away 3. And you can see that's going to give us 1201. Now in this case, we haven't actually found a solution to a specific equation. That's going to happen when we look at a practical question. I just need you to be familiar with this type of notation and what it means. Just to be clear, you will always be given the first term to use. You don't have to ever guess that or work that out. A couple of practice questions just to check your knowledge. If you're very confident with this, you can skip ahead slightly, but here's question 1. Pause the video and have a go. And then I'm going to show you the first 3 answers for question 1. Okay, here come the answers in 3, 2, 1. So you should get 11, 32, and 95. And then question 2, put your values in to work out the second, third, and fourth term. Okay, so here are the answers in 3, 2, and those are the values you should have got. Okay, let's go to a practical question.